Hello and welcome. In this episode, we will be talking about variables. Now, first of all, let's define what a variable is. In programming, you are constantly dealing with data. And a variable is a way of naming and referencing a piece of data. So, for instance, if we had an x value that was equal to the whole number integer 10, and a y variable that was equal to the floating point, or a number with a fractional part of 100, this is how we would do it. So x is equal to 10, which is an integer because it has no decimal point, and y, which is equal to 100, but it's a floating point because it has a fractional part. Now we can print these out. And what I'm going to do this time, go and bring up a shell. Forgive the ugliness. Let's go ahead and make this an executable, since I didn't beforehand. Oh, change owner. Nope, I want mode, not owner. There we go. Now, you'll notice it's a whole number 10 and a fractional and a 100 with the fractional part of 0. Okay. So now if we go back over here, one of the kind of cooler parts of Python is that you can actually set multiple variables at the same time. So for instance, we can set both x and y at the same time. And the other interesting part is that it's what's called a dynamically typed language, which means that we can change the type of a variable at any point in our code. So let's say that we suddenly decided that x should not be an integer, but instead should be a string that contains blue. And our y should no longer be a float point with 100 in it, but instead should be an integer with 42. Let's once again print these out. And you'll notice that the first print will still be the same, but now the second print will have blue and 42. So there we go. So once again, our first print is exactly the same, and our second one says blue 42. So, what else can we do? What other types are there in Python? Well, so with the basic types, that's it: integer, float, and string. But there are also three collections that are built in. The first is a list, and it is denoted with the square brackets. So if you put inside of square brackets a comma delimited list of objects, so for instance, this string, and lists can have whatever in them. So if we suddenly decide, you know what, I want to put an integer in here, we can do that. And then we can put more strings, more strings. And the important part about a list is that we can actually add to the list at runtime. So let's see how that works out for us. So you'll notice it prints it out almost exactly the same way that we wrote it, except now at the end, it actually has the runtime at the end. So lists are great for containing lists of variables that you need in some particular order. the second of our three built-in type collections is the tuple, and that is done using parentheses. And again, it can have whatever in it. Including that list. But it's read-only. So we will get an error if we try and add to it at runtime. So you'll notice that it prints not only what was in it, but also everything that was in the list, because we had we embedded the list in it. And the last data type, or data collection type, whatever you want to call it, is what's called a dictionary or an associative array. Now, this is a little bit more complicated. To define this one, use the curly brackets. And a dictionary is defined as is defined by both keys and values. So that means for every item that you want to store in here, you need a key with which to reference it. So, for instance, we could store a name, and that would be our key, and then we put a colon, and then we would put our value. So in this case, Bob. So now we have the key in this dictionary of name, which contains the value of Bob. And just like with lists and tuples, you can use whatever types of data you want for both the key and the value in this. So for instance, we could store with the key of 42 that list, or with age we could store 42.3. And if we print this, we'll see all of that. But I'm also going to show you how to reference it. So that's something that I haven't talked about. If you want to reference an individual component in these, for the list, you would do list, and then you would do the place in this that corresponds to the value that you want, the variable that you want. But it starts with 0, so this right here, this first element, this, would be at 0. And so we'll access that with that one. And it's the same thing with the tuple. So with the tuple, to access can have whatever, right here, we'll do 0. But for a dictionary, it's a little bit different. So for a dictionary, instead of putting in a integer denoting where this is, where the value is in here, we use that key that we defined. So for instance, name would return our name, and dictionary 42 will return that list. So let's go run this over here real quick. All right. So up here we had our list, and if you recall, we grabbed that first item, which was this. Now notice it doesn't have the quotation marks around it, because this is actually printing out the string, which means it doesn't need the quotation marks around it. It's just that string, and it's the same thing with can have whatever down here. Again, it's the same thing with name, the named value, or the value associated with name, which is a string with Bob. Here's that dictionary. It looks exactly the same as we defined it. And then if you recall, we grabbed the name key, or the value for the name key, which was Bob, and the value for the 42 key, which was this list. And one last thing is we can grab from the console we can grab a variable as input. So for instance, we can once again use y and have it input. We can use input to display a string, get key, and then we can print has or getting key, and then print that key, and then we can print dictionary, and then that, which will then try and get whatever key we set this equal to. So let's see this in action. So it's asking me for the key that I want to get, and this time I'm going to say age. Notice I'm not putting it in quotation marks because this is the contents of that string, and we get 42.3. Now, something important to note on this: if you try and access something that is not a key, it's going to crash. There are ways to handle this. This is called an exception, and we'll get into how to handle that later. Another thing that's helpful to know is that if you need to, what's called cast, if you need to force a variable into a different type, for instance, you have an integer that you want to be a float, or float that you want to be an integer, or even a string that you want to be an integer or float. To do that, for an integer, you would do, say instead of a key, we wanted to force this to an integer. Well, we didn't want a string, we wanted to make sure it was always an integer. We would say int, and then parentheses, and put whatever it is inside of there. We could do the same with a float, which would give us a floating point, and if you want a string, str, and that'll do it. But for now, that's variables, and we'll get into more next time.